Hello guys, in this video we are going to discuss the solution of the problem split array in 3 equal sum subarrays. So let us look at the problem statement. The problem statement says given an array ARR, determine if ARR can be split into 3 consecutive parts such that the sum of each part is equal. If possible, return any index pair I, j in an array such that sum of array ARR 0 to I equals to sum of array ARR I plus 1 to j is equals to sum of array ARR j plus 1 to n minus 1. Otherwise, return an array -1, -1. So for instance, if this is the array which is given to us, it is possible to split the array into 3 parts such that the sum are equal. And those 3 parts would be 1 plus 3, 4 plus 0 and 4. As you can see, sum of each of these parts is equals to 4, because of which it is possible to split the array into 3 equal parts, because of which we are returning true. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is, since the array can be divided into 3 equal parts whose sums are equal, because of which we can say that let us assume that the part sum is S1. So the sum of the first part is S1, because of which the sum of the second part is also S1 and the sum of the third part is also S1. So we can say that S1 plus S1 plus S1 is equals to S, where S is the sum of the array. So from here what we can conclude is 3S1 equals to S, which simply means if the sum of the array is not a multiple of 3, then it is not possible to divide the array into 3 equal parts. So let us understand this point one more time. If the sum of the array, so since we know that 3S1 is equals to S, which simply means that the sum of the array, this part, should be multiple of 3. If this is not the case, which simply means if the sum of the array is not a multiple of 3, then it is not possible to divide the array into 3 equal parts. If it is possible to divide the array into 3 equal parts, which simply means that the sum is a multiple of 3, then we will go ahead and find the index. So that's the general idea behind solving this problem, folks. Now let us take an example in order to understand this. So let us say this is the array which is given to us. Over here the sum of the array, and let us denote this sum by S, is equals to 12. Since 12 is a multiple of 3, because of which it is possible to divide the array into 3 equal parts. Folks, please note, it might be possible that the sum of the array is a multiple of 3, but still it is not possible to divide the array. So if this condition is not satisfied, then we know for sure that it is not possible to divide the array into 3 equal parts. But if this condition is satisfied, then we have to search for those 3 equal parts. So in this case, it is possible to divide the array into 3 equal parts. Now let us search for those 3 equal parts. So for that, what we are going to do is we are going to take I equals to 0, which is the iterating counter, and we are going to take S1, which is equals to 0. S1 is the sum of the first part. Now we are going to iterate on the array and we are going to compute the sum. And that sum is something which we are going to store it on S1 variable. And we are going to do this operation while S1 is less than S of 3. So let me write it down. While S1 is less than S of 3 and I is less than ARR dot size of the array. In such case, all we have to do is S1 is equals to S1 plus ARR I, and we are going to increase our I by 1. And when this loop ends, we have found the first part. So when the loop ends, what we are going to do is we are going to check whether S1 is equals to S by 3. If S1 is equals to S by 3, then we have found the first part whose end index will be given by I minus 1. And let us say if S1 is not equals to S by 3, then in such case it is not possible to find the first part, or it is not possible to find the parts, because of which we just have to return -1, -1. So that's the general idea behind solving this problem, folks. Now let us do a quick recap in order to consolidate our understanding. So the first thing which we are going to do is we are going to compute the sum of the elements of the array. Then we are going to check, and let us say this sum is something which we are storing it in a variable S. So this sum is there in the variable s. Then we will go ahead and check whether s modulo 3 is not equals to 0. If s modulo 3 is not equals to 0, then we are just going to return -1 comma -1. Please note folks, this is the case where the sum is not a multiple of 3, in which case it is not possible to divide the array into 3 equal parts, because of which we are returning -1 comma -1. Once we are sure that it is possible to divide the array into 3 equal parts, then we will go ahead and search for those parts. And if we found such parts, then we are going to return their indices. Otherwise, we are going to return -1 comma -1. And that's the whole idea behind solving this problem, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find the split and an array is given to us. So for this, the first thing which we are going to do is we are going to take s, which is equals to 0, which is the sum of the array. And then we are going to iterate on the element of the array. So for element in ARR, and all we have to do over here is s plus equals to element. And then let us check whether it is a multiple of 3 or not. If s modulo 3 equals not equals to 0. So if this is the case, it is not a multiple of 3, in which case we can safely return -1 comma -1. If this is a multiple of 3, then we have to find the indices. So let us find the indices. So for that, let's take I as an iterating counter, s1 as the sum of the array or the sum of the first part, and initialize them to 0. Then we are going to iterate on the elements of the array while I is less than arr.size, I is less than len of array, and s1 is less than s by 3. And in this case, all we have to do is s1 will be equals to s1 plus arri, and then let us increase our I by 1. And after computing the sum of first part, let us check if s1, the sum of first part, is equals to s by 3. If s1 is equals to s by 3, then the index will be given by I minus 1. Since we are doing I minus 1, for that there is an extra condition we have to place, which is if I equals to 0. In such case, rather than using I minus 1, we are going to use I itself. So answer dot append I. Otherwise, if I is not equals to 0, in which case we can safely insert I minus 1. Please note folks, this extra condition is only to safeguard when I is equals to 0. And let us say if s1 is not equals to s by 3, in which case we can directly return -1 comma -1. And in this way we will be able to find the first part. Now let us find the second part as well. So for that, let us reset s1 to 0 and let us redo the same thing, which is while I is less than len of array and s1 is less than s by 3, all we have to do over here is s1 plus equals to arri, and then let us increase our I by 1. And towards the end, we just have to check if s1 equals to s by 3. If s1 equals to s by 3, then we will just check if I is not equals to 0, in which case answer dot append I minus 1, otherwise answer dot append I. And if this is not the case, then in such case we can just return -1 comma -1. Otherwise, towards the end we will just return answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. For that, s equals to 0 and we are computing the sum of the element. If this sum is not a multiple of 3, then return -1 comma -1. Otherwise, there is an answer list. I equals to s1 equals to 0 and we are computing the sum of elements of the array while I is less than length of array and s1 is less than s by 3. Essentially, over here we are computing the sum of the first part. If the sum of the first part equals to s by 3, then in such case answer dot append I or I minus 1. If s1 is not equals to s by 3, in such case we can just return -1 comma -1. Similarly, we have found the index for the second part, and towards the end we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. Vector answer is there, s equals to 0, and then we are computing the sum of the array. If the sum of array is not a multiple of 3, then we are returning -1 comma -1. Otherwise, we are computing the sum of first part. If the sum of first part equals to s by 3, then in such case we are appending I or I minus 1. If this is not the case, then we are returning -1 comma -1. And similarly, we are finding the second part as well. And towards the end, we are returning answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.